Alright, diving in again here. I will put this parchment paper up and start our graph of inverse sine. It's defined in quadrant 1 and quadrant 4 before we were so rudely interrupted. And now I am going to identify something about quadrant 1 and 4 that we haven't mentioned. And so quadrant 1, quadrant 4 is where we've defined the inverse sine. But I was wondering what radian measures that includes. So it's going to go from this, whatever radian measure that is, all the way to this. So it includes these radian measures on this side of the circle. So if you looked at your unit circle, what radian measures do they line up with? Well, you may remember or look and see that this is pi over 2 and this is 3 pi over 2. But we are going to call this negative. We're going to look at, this is the positive direction, this is the negative direction. So we're going to rename this negative pi over 2, which is the exact same position as 3 pi over 2. So we're going to go from here, pi over 2, to negative pi over 2. And those are the radian measures that cover the first and fourth quadrant. I'm going to graph on this paper here, and I'm going to put in the sine function first. So the sine function goes up to 1, and I need that marked, and down to negative 1. And the 4 tick marks must be named. Pi over 2, pi, 3 pi over 2, 2 pi. And I'm not sure how much this is showing up. And then put 2 of them in the negative direction. They will actually be useful to us. Let me see if any of that shows up. Vaguely. Let me see if I can zoom in a little bit. See if that helps. Whoops. Whoa. Cool. Alright. Move this down and I think I can zoom in a lot. Sorry, this experimental filming here. So you can see. Alright. So zoom in even more. Alright, that's pretty good. Alright, so now I'm going to graph the sine function, starting at the origin, peaking, coming down, bottoming out, coming back up, and similarly on the negative side of the angles. So, with that, how do I get from y equals sine to y equals sine inverse? Well, we call our discussion, when we introduce this topic, the inverse functions switch x and y. So this is our now x-axis where the angles are, and this is our y-axis where these negative 1 and 1 are, and I'm going to switch them. The way I'm going to do that is I'm going to rotate this paper, and when I rotate it, I want this axis to become this one, and I want this axis to become this one. So that's why the rotation. So if I rotate that a quarter, like 90 degrees, and I'll try to retape it again. So it'll sit there for a second. And I'll see if that shows up in your viewing screen. Let me pull it back a wee bit. Alright, so there you see what was the vertical axis is now the horizontal, and what was the horizontal is now the vertical. The only difference, so I have essentially geometrically here changed x with y. The only thing that I'm uncomfortable with is, if you notice, that's a positive 1 and that's my negative 1. And if you have rotated it like I did, I guess that's called counterclockwise 90 degrees, you'll have the same situation. So in order to get the positive 1 on the right and the negative 1 on the left, I'm going to flip it over. And that's why I'm using this skinny or thin paper. And this is where you may not be able to see it, but I'll darken it. So looking actually through this paper now, I see that the -1 is now on the proper side and the +1 is over here. So I'll write it this way, +1. So notice that if I was to do the vertical line test, this would fail. And we are looking for an inverse trig function that doesn't fail, and that's why we need these restrictions. We can only count this graph between pi/2, which is right there, and negative pi/2. So it's going to start here, cross from pi/2, negative pi/2, and go to here. And I'll darken that. So only that section will count, because if I go any further this way or that way, it bends in such a way that it will not pass the vertical line test and be a function. So when I ask you for the inverse sine function, I will expect you to rethink that in your mind, or to memorize that I go like this: -1, 1, pi/2, negative pi/2, and the graph goes like that. And I just showed you why that was with our little parchment paper exercise. So there is the result for arc sine. So this is y equals sine inverse of x. All right. Let me zoom back a sec so you can see the top. There. All right. So we're going to do the same for our cosine, or cosine inverse. And again, I got tape stuck to my board. See if I can get that up. It doesn't take too long. There's one of them up anyway. All right, so let me zoom back to where I was. A little bigger than that. You getting dizzy? All right, y equals cosine inverse of x is going to be similar. I'm going to remember that it's defined for quadrant 1 and quadrant 2. So on the unit circle, this is quadrant 1 and 2, so we're going to go from here to here. So what values of, what radian values are we talking about? Well, this is 0 and this is pi. So we're going to be in between 0 and pi to include these two quadrants, and those two quadrants only. So, comes Mr. Parchment out, and put in here. See if I can get away with one piece of tape. And I guess I'll have to zoom in again. Hang on to your seat. I keep putting it up too high for the zoom function. I only got a minute left, but I guess I'll have to go on to the next section in a minute. Too low, too high. No wonder. Sorry to take up your time. Guess if I was taping this in class, it would take even more time with our ADDness, ADHDness, I guess is what you called it. That was funny. I'm sorry. I'm just going to put it one spot and just go with it. Should have practiced my videoing here, video taping. Alright, that'll be good enough. Alright, I'm about out of time again, so I'm going to turn off the video and do part 3.